these live streams working, because I've got my oscilloscope hooked up to the output of the inverter transformer, because what I wanted to check was loading. When I say loading, I mean to make sure that the transformer itself is healthy and it's not consuming power. It shouldn't consume power actually if it's in resonance and then it's perfectly in tune. So what I'm going to do is I'm going to use this standard 12 volt DC 200 watt inverter, which I've got it running on my 12 volt LiPo batteries. So what I'm going to do is I'm going to switch it on. Right, I've got a green light. Right, okay. And the consumption without a load on it is 270 milliamps. That's what I'm running on that power bank. So if I turn it off, right, you can see that goes to, well, about 20. Well, it's basically zero. It's just residual. It's around 20 milliamps anyway. So I'll turn it on. Try again. Sometimes it fits out on me. Hang on a minute. Stupid thing. Right, there we go. Okay, so I've got it on. It's green light. So I'll plug it in and we'll do a load test to see if the transformer is healthy and not got any problems. I did it earlier, but I want to do it on the live stream. Oops. Right, so the transformer's plugged in. Green light. And the power consumption is now 350 milliamps minus 20, so that's 330 milliamps. So we're using 330 milliamps. So the transformer is definitely running. I don't know if you can hear it. Put the phone on it. I don't know where my microphone is on this phone. Is it at that end? Is it that end? Anyway, so it's humming. I can hear it when I stick my ear next to it, but I don't know if you can. Stick my phone right on it. Oh, what have I done now? Oh, it flipped around on me. Hang on. So yeah, and we'll have a look at the waveform. And obviously it's a square wave because it's that thing is not perfect sine. But the objective is to remove pulses and spikes really. So that's the waveform, and I'm across the 36 volt winding, cyclic 12.4 volt, so that's the waveform there. So you can't expect a sine wave on that thing because that inverter that I'm running it on is square wave. It's not even a modified sine actually, but because it's going for the inverter transformer, it will smooth out the corners a bit. I can see, well, kind of a little bit. It's not perfect, but the objective is to remove spikes, you know, as in high voltage spikes which would damage equipment. And it seems to, I don't know if that inverter produces spikes, to be honest with you. That particular 12 volt one, I have no idea if it would do it, but I know for a fact that the generator, the petrol generator, almost certainly will produce some spikes, because I've heard some stories about how high voltage spikes from the inductions, when the brushes, the slip rings, I covered that in the previous live stream, but when the slip rings are running, the carbon brushes can arc and you get a lot of spikes on it, and that's what destroys your equipment. And so the objective is for this to snub out the spikes. Now I'll put the lid on the junction box now, so it's all sealed up. And because it's only consuming well, minus 20, 330 milliamps, it's not going to get warm, is it? It's definitely not going to get warm. So yeah, I thought I'd show you that anyway. So I know it's safe to connect up to the petrol generator if we have power cuts and blackouts, and if I need to plug this into the if I need to run any appliances, like for example that are sensitive on it, I could just plug this in parallel obviously with the output, and it would snub out some of that noise that we would normally get. I've just got to put the handle on, I suppose, but anyway, that's just an update on that. Thanks for watching.